This is lesson 15.5, and the focus is, how are special quadrilaterals related to each other? You have learned about the properties of special quadrilaterals. Today you will learn how the quadrilaterals are related to each other. I want you to think about, where would you see a trapezoid in real life? This one's a little tougher, but some possibilities could be the base of a building, or maybe even a shadow. How about, where might you see a rhombus? One possible example of a rhombus would be a baseball. Please pause and copy the following chart into your notebook. On your chart, I want you to write the letter of each quadrilateral at the bottom that matches the name of that specific quadrilateral. For example, first, find all of the trapezoids at the bottom, and any shape at the bottom whose letter is a trapezoid, please write that letter on the chart, and then do the same for the other types of quadrilaterals. Please pause and do that now. So let's start first with the trapezoids. Remember, a trapezoid has exactly one pair of parallel sides. We can see that shapes R, O, and S all have one pair of parallel sides, making them trapezoids. Next, let's look for the parallelograms. Remember, parallelograms have exactly two pairs of parallel sides, and the opposite sides are the same length. The quadrilaterals that match these properties are G, L, M, V, and N, since they all have two sets of parallel sides and their opposite sides have the same length. Next, we're looking for rectangles. Keep in mind, rectangles are parallelograms, so they have two sets of parallel sides and opposite sides the same length, but in this case they also have four 90-degree right angles. As we can see, quadrilateral G is the only one that matches these requirements. Now we're looking for squares, and remember that a square is a rectangle. However, it also has four equal sides, and as we can see, there are no squares here shown at the bottom. Last, we're looking for a rhombus. As we can see, quadrilateral V fits the properties of a rhombus, since it is a parallelogram but also has all sides of equal length. Please check your chart and make any corrections as necessary. You may have noticed the quadrilaterals Q and U did not fit into any of our categories on our chart. They're still quadrilaterals since they're four-sided figures, but since they don't have any parallel sides or any of the other properties, they are simply known as quadrilaterals. Using our chart, we can also see that certain quadrilaterals show up in more than one area of the chart. For example, G is both a parallelogram and a rectangle, and V is both a rhombus and a parallelogram. This helps show how special quadrilaterals are related to each other. Please make sure you took good notes and bring them to class tomorrow.